Hello, and welcome to section 6.2. In this section, I'm going to have two separate sets of videos. I will have two videos going over trigonometric integrals, and by this I mean integrals involving trig functions, for example, integral of sine cubed of x dx, or something like more interesting like the integral of tangent cubic of x times secant to the 7th power of x dx. And then there will be a second set of videos. I'm going to say here second set of videos involving trig substitution. And this is, by that I mean, we're going to deal with integrals that have no trig function, something like the integral of root of 9 minus x squared divided by x dx, right? You look at that top, and the fact that you have a difference of two squares, that looks like it could have something to do with the Pythagorean theorem, okay? So then we're going to look at this type of problems first, and then we're going to look at trig substitution. So let's get started. So say I want to compute the integral of sine cubic of x dx. I look at it and I think maybe u substitution, but no, because there's nothing inside sine that could be the u function. There's no derivative here, so that doesn't work. Also, if I try integration by parts, I'm going to get to something even harder, right? If you make u equal to sine cube of x, then the derivative is something even more complicated, so that doesn't really help. So then we have to think of other ways, like we have to think of the properties and the theorems that we know about trig functions. So for example, well, I can write sine cube of x dx, I can write it as sine square of x times sine of x dx. And that helps a lot. That helps a lot because we know that cosine square of x plus sine square of x is equal to 1. I can solve for sine square of x, and I get that sine square of x is 1 minus cosine square of x. So now by doing so, by substituting my sine square with 1 minus cosine square of x times sine of x dx, now it looks like, hey, here I have cosine and then the derivative is sine. Okay, one more time, here I have a cosine and here I have the derivative, which is sine. So what do I mean by that? Let me say here, if I say let u be equal to cosine of x, then du, it's negative sine of x dx, okay? Then that tells me that negative du, it's equal to sine of x dx. Therefore, sine of x dx is just negative du, okay? And then here, this is u squared. So I can rewrite my integral, and now I get for my integral that this is equal to the integral of 1 minus u times negative du, okay? Times negative 1 minus u squared times negative du. So I can simplify this. And I get that I can distribute that negative and get that I'm actually finding the integral of u squared minus 1 du, which is equal to u cubed divided by 3 minus u plus a constant. And then as usual, you have to go back to x. So let me make a little note. Back to x. You have to go back to x. So that tells me that my answer is cosine of x cubed divided by 3 minus cosine of x plus a constant, okay? Very cool, right? Very cool. So let me give you like a little, what I like to call a plan of attack, but this is just like a strategy. So if you have that cosine has odd powers, then save a factor. Save a factor so that you can write cosine square or cosine square of some other power, right, as this. And then we're going to do the same thing if we have that sine has an odd power. If that's the case, we again save a factor of sine in this case. Save a factor of sine in this case, and we're going to use the fact that sine of x is equal to 1 minus cosine of x. Now, if you're saving a factor of cosine and using the fact that cosine squared is equal to this, then you're going to use u equals sine of x for your substitution. And then if you do the opposite, if you're saving sign, then your u will be cosine, okay? Now, if the powers of both sine and cosine are even, then we're going to use the half angle formulas, which are right here. This is sine square and cosine square, okay? And then sometimes even remembering the fact that sine of x, cosine of x is equal to 1/2 sine of 2x is helpful, okay? But it all depends on the problem. So let's do another example. So now we have to evaluate the integral of sine squared of x times cosine cube of x. So then again, go back to what I just showed you. Here we have sine has an even power, and then cosine has odd power. Whenever we have that cosine has odd power, we are right here. If cosine has an odd power, save 1, write it like this, and then use u as sine of x. So let's make that happen, okay? So I go here, and I'm going to rewrite my integral. I'm going to rewrite my integral as, well, I leave my sine square of x alone, and then I write my cosine cube as cosine square of x times cosine of x dx, okay? By doing so, I can rewrite this, and I get that this is just sine square of x. We know that cosine square of x is equal to 1 minus sine square of x, okay? And then we have our cosine of x dx. One more time, we have sine square, sine square. I'm writing cosine square as 1 minus sine square, and then cosine of x, cosine of x. Okay, so what do I do next? Now I can use the fact that even my little strategy, my little plan of attack told me to. Now that I rewrote it, now that I used the fact that cosine squared is 1 minus sine square, I'm going to do it up here. I'm going to let u be equal to sine of x. And then that tells me that du is equal to the derivative times dx, okay? So then cosine x dx, that is just du. And then here, since u is equal to sine, I have u squared and then 1 minus u squared. So what am I left with? I'm left with the integral of u squared times 1 minus u squared du, okay? Which if I distribute that u squared, I get u squared minus u to the 4th du, okay? And this is just u cubed divided by 3 minus u to the 5th divided by 5 plus a constant. And then as usual, you gotta go back to x. So the actual answer, you have to express it in terms of the original variable. So back to x. So what do we get? This is sine of x cubed divided by 3 minus sine of x to the 5th divided by 5 plus c. Make a little note, okay? Make a little note so that you realize that whenever we say, let me use yet another color for this, let me use green. So make a little note so you don't forget the notation. If we say sine and there's a 2 there, that actually means sine of x and then squared, okay? This is important for you to remember because I'm going to use either notation. Awesome. So let's do another. Let's do one more example, and then that'll be it. Example number 3, we have to find the integral of cosine to the 4th x. And then again, go back to the little plan of attack. If the powers, I'm here now, if the powers are even, then use this formula. Use the fact that cosine squared is equal to, well, 1/2 times 1 plus cosine of 2x. So let's try that, okay? All right, so I'm here now. Perfect. So I'm going to use the half angle formula, okay? So one more time, we know that cosine square of x is equal to 1/2 times 1 plus cosine of 2x, okay? So then I use this information to write my integral as cosine square of x times cosine square of x dx. Then I'm going to replace each of the cosine square with my theorem here. So I get that this is just equal to the integral of 1/2 times 1 plus cosine of 2x, and then times 1/2 1 plus cosine of 2x dx. Okay, I'm going to simplify that a little so I'm not, I don't get something too weird here. So let's do it real quick. I'm going to multiply 1 over 2 times 1 over 2 and take it out of the integral, so that's a quarter. And then integral, then we're going to FOIL this thing, okay? I'm going to do 1 times 1, I get 1, and then if I do 1 times cosine of 2x, right, plus 1 times cosine of 2x, I get plus 2 cosine of 2x, and then plus cosine square of 2x when I multiply cosine of 2x times cosine of 2x. Perfect. Now, I know what cosine square of x is, but I need to find what cosine square of 2x is, okay? Well, the same way that cosine square of x is equal to 1/2 times 1 plus cosine of 2x, right? This is the half angle formula. So if I take cosine square of 2x, which is what I want now, if I take cosine square of 2x, so cosine square of 2x, then this is just 1/2 times 1 plus cosine of 4x, okay? And so on. Okay, perfect. So then what do I have? I go back to my integral, I put everything together. I have 1 over 4 times the integral of 1 plus 2 cosine of 2x plus, and then replace cosine square of 2x with 1 plus, so this is 1/2 times 1 plus cosine of 4x dx, okay? Very nice. Very, very, very nice. Perfect. Okay. So what do I have here? Now I can do this. I can integrate this one by one, okay? So this is just, let me just do 1 over 4 and then 1 plus 2 cosine of 2x plus, I'm going to distribute this 1/2. I get 1/2 plus 1/2 cosine of 4x dx. Now I can even put together this 1 and this 1/2. So if I put together that 1 and the 1/2, what do I get? I get 1/2 plus 1, that is just 3/2, right? So let me put it up. So I get that this is 1 over 4, and then 1 plus 1/2, I get 3/2 plus 2 cosine of 2x plus 1/2 cosine of 4x dx. And I think I'm ready to compute this again. I'm going to do this one by one. So what do I get? I get that this is equal to 1 over 4, and then the integral of 3/2, that is just 3 over 2x, plus the integral of 2 cosine of 2x, well, that's just 2 sine of 2x divided by 2, plus 1/2, then the integral of cosine of 4x, it's again just sine of 4x, okay, divided by 4, and then I had to add a constant, so plus a constant. So that's a little messy. Let me take it with me and simplify and make it look pretty on my next page if this allows me to do it. Let's see. Perfect. I'm going to copy it, and then another one, then right here, paste. So this is what I had. Pretty ugly. Let me make sure that it makes sense. So plus a constant. So this is equal to, simplify it, 1 over 4, and then 3/2 x plus sine of 2x plus 1 over 8. So sine of 4x divided by 8, and then add that constant. So let me just mention something real quick. So notice that I didn't prove that the integral of cosine of 2x dx is equal to sine of 2x divided by 2 plus a constant. You can check that out by just you can see that this is true, right? By computing the derivative of the right hand side. You'll get cosine of 2x divided by 2 times the derivative of 2x. So I just think that you have to go through this process at least once and really understand that we're allowed to do this because the argument, right? What's inside cosine of cosine is a constant times. So I'm going to say a constant, let's say a times x, where a is a constant, okay? So again, go through this at least once. So if I have that, I'm computing the integral of cosine of a number times x. By a constant, I mean a number. I have a number times x, then you say, well, let u be equal to ax, then du is equal to a dx, and therefore it'll always be true that dx is equal to du divided by a. So dx is equal to du divided by a, and ax is equal to u. So you rewrite your integral, you get that this is just the integral of cosine of u du divided by your number. Take that 1 over a out, cosine of u du, and this is 1 over a, and then we have sine of u plus a constant, and you always have to go back to x, 1 over a, sine of u, which is ax, plus a constant, okay? Well, that's it. That's all I have for you for this particular section, this particular video. Stay tuned and watch the rest of the videos, okay? Bye-bye.